When a relationship exists between two variables, again, we denote one as the input, the other as the output. And then there's actually several ways we're going to talk about in this course on how to describe the relationship between two variables. And one is a numerical description. And that's simply a table of values. Completely filled in, indicating the relationship between the two variables. Or we can think of it as, or one way to describe numerically the relationship is through a collection of ordered pairs. So I'll give you an example of both of these here. So this is number 2. Write a numerical description of the relationship between the variables here in this one. So what's the relationship here? So we're looking for a numerical description to describe to our audience what the relationship is, and we're going to take this first one, a table of values. Well, you need a table here, which you don't have. Let's make one. Here's a table. And always, always, always in a table of values, whether you're working vertically from top to bottom or horizontally from left to right, the first one listed will always, or the first row or place in a table will always be taken by the input variable. For us, the input variable is the total cost. So here's the value of associating a letter. Let's say, let's use a letter for the total cost. Hopefully you're thinking C. Let's let C be the total cost, and we'll put T as the tip amount. So the input variable goes first in table format, so the total cost of your meal and then your tip here. So when you go out to eat by yourself, again, sorry, let's say you go to, I don't know, Filiberto's and you get an $8.50 meal. I guess there's no tip there, but let's say you want to leave a 20% tip. How would we calculate that? Well, you take 8.5 or $8.50, hit it with 20% in decimal form, and that's how you calculate 20% of the total bill there. It's a $1.70 tip. So right away we see that a $1.70 tip is associated with a total cost of $8.50, and vice versa. Let's do another. Let's fill in, I don't know, 4 more slots, I guess. Let's say you go to another place, order a dessert by yourself somewhere, maybe Rubio's. I guess you still wouldn't leave a tip, but let's say you do. $12 multiplied with 20%, that gives you $2.40. So this table is really describing the relationship between these two variables just in a numerical format. Let's do 2 more. Let's say you try to celebrate something. You go to Cheesecake Factory by yourself. $16.90. $16.90 times 20% gives you $3.38. So that's what you should leave. And let's do one more amount. $32.05. Let's say you have a couple drinks with your meal, and so $32.05 is 20% here. $6.41 is what you should leave. Okay, so this is a numerical description, and we say this table, completely filled in, completely describes the relationship between the total cost of your meal and your tip